All right, grade 11 university, we're on quadratics day 5, and we're on solving quadratics or finding the x-intercepts. I could also say finding the roots, solving, finding the x-intercepts, the zeros, it's all the same question. So for the first one, we have it in factored form, which is the nicest way to find x-intercepts. Most of you would recognize that if you had y equals x minus 5, x plus 3, that your two x-intercepts are 5 and minus 3. And the reason is that when we're looking for x-intercepts, we are looking for when y is equal to 0. So setting that equal to 0, we are doing that. If you have two things being multiplied together to give you 0, then x minus 5 is equal to 0, or x plus 3 is equal to 0. Both of those would give you a 0 for y, which is why we would say x equals 5 or x equals minus 3 for the two solutions to that 0. The second one is also in factored form. If we want our x-intercepts, which are a little trickier when they're like that, we're doing the same process in our heads. We are saying for x-intercepts, y is always equal to 0. So if I set that equal to 0, then I have 0 equals 3x plus 1, 2x minus 5. Then it would be true that either the first bracket is equal to 0, or the second bracket would be equal to 0 for me to get a 0. For the first one, I'm going to subtract 1 from both sides, and then divide by 3. So one of my x-intercepts is minus a third. For the second one, I'm going to add 5 to both sides, and then divide both sides by 2. So my second x-intercept is 5 halves. So the first one is minus a third from the first bracket, and the second one is 5 halves from the second bracket. For the third one, I don't have it in factored form, but if I could write it in factored form, I would know my x-intercepts. If I rewrite that, because it's a simple trinomial, there's two sets of brackets, x and x, multiplies to 3, adds to 4. It's beautiful to factor. Then I know that either this bracket is equal to 0 and I have an x-intercept of minus 3, or this is equal to 0 and I have my second x-intercept as minus 1. Fourth question is asking the same thing in a different way. Finding the zeros for something is the same thing as finding the x-intercepts, or finding the solution when y is equal to 0. So, to find my x-intercepts, I can do that in two different ways. I can factor, where I take out a common factor of 2. Notice that it's a nice difference of squares, x minus 7x plus 7, and then realize that either this bracket is equal to 0 and one of my x-intercepts is 7, or that bracket is 0 and I would have an x-intercept of minus 7. The second way to solve for this 0, x squared minus 98, can only do one thing at a time, is to add 98 to both sides, divide both sides by 2, and impose a square root, which would give me x could be positive or negative 7. Y equals 3x squared plus 11x minus 4 is not in factored form. To find the x-intercepts, I'm going to try and factor it. It is a more difficult trinomial, so I would have to decompose, where the two numbers would add to 11 and multiply to minus 12. My two numbers would be 12 and minus 1. So I'm going to decompose it as 3x squared plus 12x minus 1x minus 4. We would factor by grouping. Greatest common factor for those two terms would be 3 and x, left with an x plus 4. I want my next two terms to have the same in the brackets, an x plus 4, so I'm going to factor out a minus 1. Then I would rewrite that as the common factor of x plus 4 times the leftovers. Now that I have it in factored form, my two x-intercepts are minus 4 from when this could be 0, or, be careful, positive 1 over 3 when that becomes 0. The last one on this slide is solve for z. That's the same problem. I'm looking for a solution to my problem. I'm going to write it in a form that I'm more familiar with. I'm going to add z to both sides. So I'm looking for the solution, or when this problem is equal to 0, which we could call the zeros of that equation, or the z-intercepts if I were to graph it. I'm going to try and factor this, and thereby getting my z-intercepts or solutions. Z and z, it looks like a simple trinomial. I want to multiply to 30 and add to positive 1. So I need to use 6 and 5, where my 6 is positive and my 5 is negative. That means I have two possible solutions of negative 6 or 5. But sometimes it is not easy to factor, or we are not given the equation in factored form. So we need other strategies. For our first one, we are looking for the x-intercepts. So I could go through the process of expanding and factoring, which is painful. But I do know that for x-intercepts, my y value is 0. So I am going to try a different strategy with my arithmetic. I'm going to subtract 1 from both sides. I am going to divide both sides by negative 3. I'm going to impose a square root on both sides. So I need to remember to consider the positive and the negative square root of a third. And I'm going to add 7 to both sides. That is a fine way to write your x-intercepts, but it can be a little bit confusing. That means your x-intercepts are ugly, and one of them is 7 plus root of a third, whatever number that might be, and the second x-intercept is whatever 7 subtract the square root of 1/3 is. Minus a half x squared plus 2x minus 1. We know for x-intercepts our y value is equal to 0. Finding x-intercepts from this form is very difficult. So I would either like to put it into factored form, which won't work, or into vertex form and solve it as we did the one above. So my starting point is to factor out the minus 1/2. X squared. If I want to end up with 2x, I need a minus 4x here, so that if I did distributive law, I would get the line before it. I'm just doing a mental check. Plus 2, because minus a half times positive 2 is minus 1 that I wanted. There we are. I just don't like that minus half in the front. And since I have this whole thing equal to 0, I can divide both sides by minus a half, and I have simplified this a great deal. It's still not factorable, but I have something much more simple that I could complete the square with in order to solve it like I did the last question. So to complete the square, there's short form for you. I am going to skip a line, put my goal down, of x minus half of the 4, which is 2. That means I need to introduce whatever this is squared, which is a 4. So I'm going to add and subtract 4 into the problem. I did that to complete the square so that those 3 terms are my beautiful square down here, and the leftovers are minus 2. Now I can solve as I did above. I'm going to add 2 to both sides. I'm going to impose a square root on both sides so that I'm going to be thinking about the positive or negative square root of 2, and then add 2 to both sides. Those are my 2 x-intercepts. If it is clearer to you to write them as points, the first x-intercept is whatever 2 plus square root of 2 is, and whatever 2 subtract square root of 2 is. Those are my 2 solutions. Our next problem is the same idea. I am going to find solutions for x, so I'm going to write it in quadratic form that I'm used to by subtracting 2x from both sides and adding 6 to both sides. Now I have a quadratic equation equal to 0, and I have strategies for that, either to factor or to write it as a completed square in vertex form. No matter how we approach this one, it's going to get ugly. I'm going to factor out a minus 5. Be careful. If I factored out a minus 5, I need a positive, and I need 2/5 x, so that if I multiply minus 5 times the 2/5, I get minus 2 as I had before, plus, no, subtract 6/5, so that if I were to multiply by negative 5, I would get what I started with. I'm going to divide both sides by minus 5 because it's just ugly. And I need the solution to that problem. It would not be easy to factor that. I'm going to complete the square and solve as we did above. For completing the square, I need to add and subtract a factor into this line, so I'm going to leave it blank and go for my goal, which is x plus half of the 2/5 x term. Half of 2/5 is 2/10. So that is my goal. I need to add into the equation whatever 2/10 squared is. So I'm going to add 4/100 and subtract 4/100 to this equation. There. The first 3 are that beautiful square that I was aiming for, and the leftovers, well, I need a common denominator for those. So I'm going to change them both to hundredths, multiplying that second one by 20/20, and almost done. 0 equals x plus 2/10 squared minus 124/100. To solve for x, I'm going to add 124/100 to both sides. I'm going to impose a square root on both sides, remembering to consider both the positive and the negative. And lastly, I'm going to subtract 2/10 from both sides. I can simplify those a little bit, but those are my 2 x-intercepts. There is no reason that x-intercepts have to be beautiful integer numbers. They can be quite hideous, as you can see. Tomorrow we'll give you one more, much easier strategy to help deal with ones that are this ugly. Let's do one word problem before we work on homework. For example, you have 2 squares whose side lengths are consecutive odd integers and have a total area of 650 centimeters squared. What is their total perimeter? if you have a little square whose sides we've decided to call x, and these side lengths are consecutive odd integers, that means the next one in size is going to be 2 larger than the small one because they're consecutive odd numbers like 11 and 13 or 15 and 17. The difference between the two side lengths would be a factor of 2. We have been told that the area is 650. We have been asked to find total perimeter. To find perimeter, we would really like to solve for x. That means we're going to have an equation where we are looking for the solutions for x. That is really finding the x-intercepts if we have a quadratic equation. Area is length times width. And the total area of both of them is 650. So the area of the first one would be x squared, and the area of the larger one would be x plus 2 squared. So the area would be x squared plus x plus 2 squared. And we know that the total of that is 650. We do indeed have a quadratic equation for which we are trying to find the solutions for x. We have strategies to either factor or use completing the square to solve it. So let's tidy it up first and see what we get. X squared, I'm going to FOIL this, and I'm going to subtract 650 from both sides and have it set equal to 0. So I need to tidy that up. 0 equals x squared plus, first, x squared outside and inside together would give me 4x. Last would give me 4 minus 650, almost there. 0 equals x squared, 2x squared plus 4x minus 646. Well, I certainly see a greatest common factor of 2. So I can at least simplify it that far. Maybe that's nicely factorable. It is actually. 323 is 17 times 19. So we could factor this if we're really clever. X, 19, 17. I want the larger one to be positive. Therefore, my x value could be negative 19 or 17. We'll talk about those in a moment. But not everybody would recognize that 323 is divisible by 17 and 19. So if we had to, from this line, we could solve it by completing the square. Since that's equal to 0, I would divide both sides by 2. To complete the square, we skip a line and write our goal, which is x plus always a half of that number, x plus 1 squared. If I want an x plus 1 squared, I need to introduce this number squared, which happens to be 1. So I'm going to add and subtract 1 to the equation, which doesn't change it. So that the first 3 terms give me my beautiful x plus 1 squared, and the leftovers are minus 324. 0, 0. I'm going to add 324 to both sides. I'm going to impose a square root on both sides. And I'm going to subtract 1 to both sides. If you were to type that into a calculator, you would have x equals minus 1, take away 18, or x equals minus 1, add 18, which will give us our two answers of minus 19 or 17. So we could solve that in either of 2 ways. If we're good at factoring, because it goes faster, or completing the square, which is more difficult, but can get us to some really awkward numbers. That means that the value of x on my little square is either a minus 19 or a 17. It doesn't make any sense to have a length of x as a negative number. So the total perimeter I'm going to get from my x value being 17. That means that the little square is x plus x plus x plus x, which is 4 times 17. My big square is not 17, it's going to be 19, 19, 19, and 19. And of course, we'd write a little bit of an explanation beside that, but I would get my total perimeter by doing that operation. It's 144 total, and we don't have units, do we? Yep, centimeters. 144 centimeters. We're going to practice finding x-intercepts or solutions to problems. Course notes 26, 3 to 6, which is the 3 to 6 at the bottom of the page. Page 177 and 185.